Hi everyone, good day. Are you ready for another Math Venture with Teacher Rev? Let's start our statistics learning journey.
Another way of presenting data other than the textual form is the tabular form. We do this by organizing into tables. Important features about the data can be readily available and comparison can be easily done when everything is in table. Exact values are given, so it shows complete information regarding the data. But there are certain things that we need to consider to be able to construct a table. First is the table number. We need to have a table number, and normally it is placed on the topmost part, and in this case we have table 4. We have the title, which briefly explains the content of the table. Let's look at the title. This is a distribution, so it talks about number. Number of what? Junior high school students. So when we talk about junior high school, it talks about grade 7 to 10. In what school? In Makati Science High School. So we are familiar with the school, and this is done according to what? According to grade level. So without looking at the table, we already have a complete picture of what's in the data that will be presented to us. Now, given the table, we must have what we call as column header, which identifies the content in each column. It describes the data that we have for each column. Now, for the first column, normally we have the row classifier. It shows the classes or the category in which the data are presented. In this case, we have grade 7, grade 8, grade 9, and grade 10 as our row classifiers. And in this case, our column headers are grade level and number of students. So even if we don't look at this, we know that this actually talks about number. The grade level talks about 7 to 8. And the whole thing, the whole item in our data is what we call the body, which is the most important part of our table. Other than that, it's also important to have a source at the bottom part. It came from a secondary source. It is a must that we cite the source here. We cite where we got the table. For instance, if we want to know the number of recoveries, the number of recovered victims from COVID positive, if we are after that, then we can look into the OH page, Department of Health page, or if not in Department of Health, if we want to go for a global perspective, we can go to World Health Organization. They have a complete data of that. That means that we need to identify our source here, where we got it. If it's possible to write the address of where we identified it, then we need to write it here or to note it in the source. This place below table when the data written are not original. It means that out of respect for those who collected the data, out of respect for those who crafted the table, we need to cite where we got that information. So that's about the tabular method. But there are different tables that you can present in statistics. One is what we call frequency distribution table. It is a table which shows data arranged into different classes and number of cases, which will fall into each class. Now, in this case, we have frequency distribution table for ungroup. We also have frequency distribution for group, which we will talk about later. Let's go back to the ungroup first. The frequency distribution table for ungroup is simply arrangement of data from lowest to highest, which shows the frequency of the occurrence of each value in a set. So this is the data. So the data talks about the age of 50 students enrolled in statistics because the range of age are quite big. So this is ungrouped because we identified only values 14, 15. This shows that if we are to interpret our data, 4 students who are enrolled in statistics are of age 14. On the other hand, there are 13 students who are of the age 15. The age 17 in the class are 5 students. So if that's the case, these are the only information that we have. This is ungroup data. Now, when will it be group data? It will be group data if there's a category or there's a classes involved. For instance, if I do not have 14 to 15 and I change it to 14 to 15, ages 16 to 17, ages 18 to 19, then this becomes group data because there's already classes, there's already range of values. But other than that, if this is not the case, then it's only ungroup data when it is individually identified together with its frequency. So let's erase that part. Several questions will be asked about this. So this is ungroup data. We have the frequency and the items only. 50 students and so on. Now let's talk about ungrouped data. First, in the given earlier, I gave you an idea about getting the highest score and then the lowest score, then subtracting it. That's actually the range of values. Now, in this set of data, the highest value is 50 and the lowest value is 3. Therefore, the range is equal to 50 minus 3, or what we call 47. What we have 47. So the range of data is 47. Now, the frequency distribution for group data is what? Is an arrangement of data into different classes or categories. It involves data which falls into each class. Now, in this case, again, this is a raw data. From the raw data, we're going to construct what we call the group frequency distribution, which will look like this. Now, going back, how do we construct? Where do we start? The first thing that we have to identify is to get the range of values, which is 47. After getting the range of values, the first thing that we do, let's focus on the steps. Construct frequency distribution table. So when we are to construct a frequency distribution table, we have to decide on the number of classes. But take note that in terms of the number of classes, there is a note on top. It says here that to consider regarding the number of class intervals, avoid using fewer than 6 or more than 15 classes. So meaning we can have, in this case, these are the class intervals. So we cannot have lower than 6 here, or we cannot have more than 15 here. It's not recommended. Why? Because it will give us lower magnitude of range of data or high magnitude of range of data. So in this case, let the teacher give you these values, or if you want to create your own table, you may choose from 6 to 15 classes. So you decide. In this case, let's decide on 8 classes. Once we have decided, we are going to get the class width. Now, the class width is represented by lowercase I, which is solved by the highest value or lowest value, which is the range, and then the number of classes. The range earlier is 47, and the desired number of classes is 8. So 47 divided by 8 will give us roughly 5 point something, right? Okay, let's look at our calculator. Let's look at our data again. These are the important things that we need. So that would be 47 divided by 8. And you have 47 over 8, or 5.875, which is somehow 6. Now, why do we go for whole number? Now, disregard this part. When the data are whole numbers, I should be whole number. When the data are decimal, not whole numbers, decimal form in one decimal place, I should be a decimal number with one decimal place as well. So it follows the data. If we are going to look at the data, our data are whole numbers. Therefore, the I should be a whole number as well. So I is approximately 6 because it's 5.8 or 5.9. So we have the number of classes. We expect that we have 8 classes. We also expect an interval of a class width of 6. It's a whole number because the data given is a whole number. Then there's a third item. So we're done with the first and the second. Later, I'll show you how we're going to go about this. Always start with the lowest class with the lowest value. Let's go back to the data. If we are going to verify the data or to check on this data, what's the lowest value? Exactly, the lowest value is 3. Okay. If the lowest value is 3, then it says here, it is recommended that we start with the lowest class with the lowest value, which is 3, of the raw data in order to minimize the errors unless otherwise specified. Tally the frequency in each class until the highest value is reached. The last class interval can go beyond the highest value in the observation as long as I is obtained. So, okay, we have those values already. Now let's go to the table. What do we have? We have an I of 6. I is the class width. We also have the number of classes, which we say we decided on having 8, then it says there earlier, start with the lowest value, which we know the lowest value is 3. So we start here with 3 because it says here start with the lowest value. The next thing is after starting with the lowest value, since it's a class interval and the class width is 6, we need to count 6 units starting with 3. So we have 3, 4, 5, 6, 7 until 8. 1, 2, 3, 4, 5, 6. So these are 6 numbers. So our first class interval is 3 to 8. Can you follow? The next class interval is, we'll start not from 8 because it says here, let's go back. It says here, the lowest raw data in order to minimize errors unless otherwise specified. Make sure that each item into one and only one class. So the second reminder in terms of class interval, make sure each item is into one and only one class. So that means 8 cannot be here, so we start with 9 until what? Again, we count 6 because the class width is 6. 6 units starting with 9. So that would be, I'll erase this part, then I'll start with 6 again. Now with 9, counting 6 units. So that would be 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, and 14. So that would be 9 to 14. If I continue that pattern, I will have 15 until 20, 21 until 26, 27 up to 32, 33 up to 38, 39 to 44, and 45 to 50. We know that 6 refer to the number of items from 3 to 8. That means 3, 4, 5, 6, 7, 8. There are 6 numbers from 3 to 8. That's why the class width is 6. The class intervals are this. The first class interval is 3 to 8. The second class interval is 9 to 14. The highest or the last class interval is 45 to 50. Can you follow? Since we know already how we acquired these values, the next thing that we're going to do is to identify how is 8 related to all these values. Let's count the class intervals. We have 1, 2, 3, 4, 5, 6, 7, and 8. There are 8 class intervals. This is where the 8 comes in. The 6, which is the class width, comes in that from 3 to 8, there are 6 numbers present on that. That's how we apply the concept of class width and number of classes in our group frequency distribution. I hope you get this clear.
This had been a great learning adventure. So, see you next time on another Math Venture with Teacher Rev. Remember, don't stop until you're proud. Learning math takes time. Bye!
And I can't wait so we can break apart the